A silent, invisible message from the cosmos just arrived. It did not come from a star or a planet, but from a seemingly empty cloud of interstellar dust. This is the story of 25 such signals, cosmic enigmas that defy every explanation. By the end, you will understand the profound mysteries hiding within these dark clouds. We will explore whispers from Orion that repeat with strange precision and bursts of energy that appear to vanish without a trace. What you believe is waiting for us in the dark. It emerged from the Sagittarius constellation, a burst of radio waves so powerful it stood out against the cosmic background like a single, perfect note held in a silent hall. This was not the famous wow signal, but something even more perplexing. Its origin was traced back not to a star, but to a cold, dark cloud of interstellar dust, a place where nothing should be capable of generating such a sharp, focused transmission. The signal appeared to carry a pattern, a sequence of pulses that repeated with a clockwork regularity that defied all known natural processes. Imagine a metronome ticking in a vacuum, each beat perfectly spaced from the last, a rhythm that felt almost intentional. Scientists were left with a profound puzzle. Natural cosmic objects like pulsars do produce rhythmic signals, but they are born from the violent spin of dying stars. This signal, however, came from a quiet, unassuming dust cloud, a cosmic backwater where no such stellar remnant exists. The pattern was too clean, too precise, echoing the mystery of the wow signal, but with a new, unsettling twist. It was as if we had overheard a fragment of a conversation, but the speaker was hidden in a thick, impenetrable fog. Could this be the signature of a natural phenomenon we have yet to understand, or does it point to something else entirely, a message deliberately cast into the void from behind a dusty veil? That single, perfect note from the dust cloud forces us to ask the most difficult question of all. What could possibly create it? The first and most logical place scientists looked was towards pulsars. These are the spinning corpses of massive stars, lighthouses of the cosmos that send out regular beams of radiation. But a pulsar's rhythm, while precise, has a certain character, a gradual slowing over eons that this signal from Sagittarius simply did not possess. Its beat was too steady, too unwavering, as if powered by a clock of unimaginable perfection. This left researchers grappling with a void of explanations, pushing them to consider phenomena at the very edge of known physics. Perhaps it was produced by a starquake on a strange, hyper-dense object hidden within the dust, or maybe it was the signature of a cosmic string vibrating through space-time itself. These are the realms of theoretical possibility, ideas that are mathematically sound but remain just beyond our observational reach. Then, of course, there is the most speculative yet most captivating theory. Could this be a technological artifact? The signal's clean, repetitive structure echoes the kind of pattern we would expect from a beacon, a deliberate transmission designed to stand out against the natural chaos of the cosmos. The greatest challenge, however, lies in the signal's own origin point. The dust cloud itself is the perfect hiding place. These vast clouds are not solid walls but diffuse veils of microscopic particles, making it nearly impossible to locate the exact source within them. It is like trying to find a single, specific pebble on a beach shrouded in a thick, rolling fog. The signal could be coming from a small object deep inside the cloud, its true nature completely obscured by the very dust that also delivered its message to us. So we are left with a choice between cosmic unknowns. Is this the first glimpse of a new type of celestial body, one that operates by rules we have yet to write, or is it something else, a whisper that passed through the dust on its long journey to us? And so the mystery deepened with a whisper from Orion. This was not a single, sharp note like the signal from Sagittarius, but something far more persistent and strangely conversational. Emerging from the vast Orion molecular cloud complex, a stellar nursery shrouded in dust, this signal arrived as a series of faint, repeating pulses. It was a cosmic tap, tap, tap that would fall silent for months or even years, only to return with the exact same pattern, as if someone had simply paused a recording before pressing play once more. This relentless recurrence is what truly baffled scientists. Natural cosmic events are often one-off cataclysms, a star exploding or two black holes colliding. They do not typically schedule encores. Even pulsars, the most reliable timekeepers in the universe, do not simply turn off and on again at will. The pattern itself was another layer of the puzzle. It was not a simple metronomic beat. It was a complex sequence of long and short pulses, a rhythm that felt almost structured, like a slow, deliberate code. Trying to classify it was like trying to fit a square peg into a round hole. It did not match the profile of any known stellar object, and it was far too weak and localized to be the product of a distant, energetic quasar. It seemed to be emanating from the dust cloud itself, a whisper trapped within the swirling particles of a cosmic cradle. The very dust that helps form new stars was also hiding a secret, a signal that repeated with a patient, unnerving consistency, challenging us to decipher its origin. Was it the hum of a natural engine we have never seen, or a message patiently repeating itself, waiting for the right listener to finally understand? The repeating whisper from Orion was soon joined by a third, even more unsettling signal. This one arrived on a frequency that astronomers know intimately, the hydrogen line. Imagine the universe's most basic building block, the hydrogen atom, which fills the empty spaces between stars. It naturally emits a faint radio whisper at a specific frequency, 1420 MHz. For decades, scientists have considered this frequency a cosmic meeting point, a logical channel for any advanced civilization to broadcast a hello, because it is so fundamental to the universe itself. And that is precisely where this new signal was found, a powerful, narrow-band transmission screaming from within a quiet, unremarkable dust cloud. The sheer power of it was the first shock. This was not a faint whisper lost in the cosmic static. It was a clear, strong signal, like a single, pure tone from a flute cutting through the noise of a full orchestra. The second shock was its precision. Natural cosmic phenomena tend to be messy, their radio emissions spread across a wide range of frequencies. This signal was laser-sharp, concentrated into a band so narrow it seemed artificially crafted. Finding such a deliberate, powerful transmission at this specific, significant frequency, but coming from a place where nothing should be, created a perfect storm of mystery. It was as if we had tuned our radios to the universe's most obvious communication channel and heard a perfectly spoken word, only to look and see the voice was coming from an empty, dark room. The implications are staggering. Was this a natural process, some unknown quantum phenomenon in the dust, that by sheer cosmic coincidence mimics the very signal we were hoping to find? Or did we, for one breathtaking moment, intercept a beacon, a message deliberately placed on the universal airwaves, its source cleverly hidden behind a curtain of cosmic dust? The dust cloud, once just a backdrop, was now the central character in a deepening cosmic drama. This strange precision on the hydrogen line was soon overshadowed by a signal that broke one of space's fundamental rules. The fourth signal arrived not as a steady beat, but as a sudden, brilliant flash, a burst of radio energy that lasted only milliseconds. At first glance, it resembled a fast radio burst, one of the cosmos's most energetic and fleeting mysteries. But this burst carried a unique fingerprint, or rather, a distinct lack of one. When radio waves travel across the vast distances of space, they interact with the sparse sea of electrons between galaxies. This interaction causes a phenomenon known as dispersion, where the higher frequencies of the burst arrive at our telescopes just a fraction of a second before the lower frequencies. It is a telltale sign of an immense cosmic journey, like watching a wave wash up on a shore with the foam arriving before the heavier water. This signal, however, showed almost no dispersion at all. Its frequencies all arrived in a tight, perfectly synchronized package, as if it had barely traveled through any interstellar medium. This was completely unexpected. It meant the signal either originated incredibly close to us, which it did not, given its pinpointed location deep within a distant dust cloud, or it came from an environment so utterly empty, so devoid of free electrons, that its journey was virtually unscattered. This forces a radical rethinking of the dust cloud itself. We picture these clouds as murky, diffuse places, but what if this signal came from a hidden cavity within the cloud, a vast, pristine bubble carved out by some unknown force? A void within the veil where the normal rules of space simply do not apply. The burst itself might have been a natural, if violent, event, but its impossibly clean arrival suggests it was born in a pocket of the universe unlike any we have ever observed. Was this empty pocket the source of the burst, or merely a clear channel it passed through, a secret tunnel through the dust that allowed this single, defiant flash to reach us in its pure, unaltered state? This fifth signal introduced a layer of mystery far richer than mere radio waves. It arrived from a dust cloud that was, at that very moment, revealing itself to be a cosmic chemistry set. Telescopes had detected the spectral fingerprints of complex organic molecules within the same cloud, compounds like formaldehyde and methanol, which are the essential building blocks of life as we know it. The coincidence was too powerful to ignore. Here was a signal, a deliberate seeming transmission, emanating from a cloud that was actively brewing the ingredients for biology. It was as if we had found a single, lit window in a vast, dark factory, and through that window we could see the very machinery of creation at work. The signal itself was not dramatically powerful or strangely patterned like the others. Its profound nature came entirely from its context, from the company it kept. Was this a cosmic signpost, a flare sent up from a place of profound chemical activity? The possibilities are staggering. On one hand, the signal could be a completely natural byproduct of that very chemistry. Perhaps the complex interactions of these organic molecules, as they form and break apart on the surfaces of dust grains, can generate radio emissions in ways we have not yet discovered. It could be the sound of life's raw materials assembling themselves in the dark. On the other hand, the presence of these molecules opens a far more speculative door. What if the signal is not a cry of random chemistry, but a marker? Could it be a beacon placed by an intelligence to draw attention to a region of space uniquely suited for the emergence of life? A sign that reads, in the language of the universe, life can start here. Or, in the most profound scenario, could the signal itself be a product of biology, a transmission from a life form that already calls that dusty, molecular-rich cloud its home? We are left to wonder if we are not just hearing a signal, but listening to the very background hum of a living cosmos, a whisper from a place where the line between chemistry and destiny is being blurred. Just as we were grappling with signals that burst and repeat, another arrived with a ghostly patience that defied them all. This sixth signal did not shout or whisper. It breathed. Over the course of several days, its intensity would slowly, rhythmically swell from near silence to a detectable peak, only to then recede back into the void with the same unhurried pace. This gentle rise and fall was completely unlike the violent explosions of supernova or the sharp, rapid pulses of a spinning star. It was a cosmic tide, ebbing and flowing with a serene, deliberate rhythm that felt almost meditative. Scientists had never recorded anything like it. A pulsar's beam flashes on and off in milliseconds. A variable star might brighten and dim over weeks, but its changes are tied to complex internal processes and are rarely this smooth or predictable. This ghostly modulation was different. It was too steady, too symmetrical, as if some vast, unseen engine was slowly inhaling and exhaling radio waves into the darkness. The first and most straightforward explanation was a binary system, two objects orbiting one another. Perhaps a dense neutron star and a common star locked in a dance, with one periodically eclipsing the other from our point of view. But the fade was not a clean, sudden cutoff. It was a gradual dimming and brightening, a smooth transition that simple eclipses could not easily produce. Another model proposed a vast, lopsided dust cloud itself. Imagine a colossal, slowly spinning disk of dust and gas, thicker in some parts than others. As this uneven disk rotates, it could gradually block and then unveil a steady source of radio waves hidden behind it, creating that gentle, rhythmic fade. Yet this would require a cloud of near-perfect shape and stability, a celestial stagehand with impeccable timing. The most exotic theory points to a phenomenon known as a precessing pulsar. This is a neutron star that does not just spin, but wobbles dramatically on its axis like a top slowing down. Its powerful lighthouse beam would then sweep across space in a wide, slow cone. If that beam only grazed the Earth during part of its wobbling cycle, we would witness exactly this kind of gradual brightening and fading over days. Each of these models is a testament to human ingenuity, an attempt to explain the unexplainable with the physics we know, but they all struggle to account for the signal's perfect, ghostly rhythm. This leaves us with a profound sense of scale. The forces required to power such a slow, steady pulse, whether from a wobbling stellar corpse or a spinning dust curtain, are almost incomprehensibly vast. We are not just listening to a signal, we are witnessing the slow, patient heartbeat of a cosmic giant, its true form and purpose still completely hidden from our view. This slow, cosmic breath was soon followed by a signal that arrived not just with a message, but with a distinct orientation. The seventh signal was highly polarized, a characteristic that sounds technical but reveals a profound story about its journey. Imagine light as a wave traveling through space, vibrating in all directions. Now picture a picket fence. If you try to push a long, flat board through it horizontally, it gets stuck. But if you turn it vertically, it slides right through. Polarization is similar. It means the radio waves from this signal were not vibrating randomly. They were all aligned as if they had been forced through a cosmic filter. This alignment tells us the signal encountered incredibly powerful magnetic fields on its way to us. The dust cloud it emanated from is not a passive, formless haze. It is a structured, magnetically dominated environment with field lines threading through the dust like invisible threads through a tapestry. This polarization is the key to its strangeness. We know of natural objects that produce polarized radio waves. Pulsars do it, their beams twisting through intense magnetic fields. But the polarization from this dust cloud signal was different. It was extreme, too pure and too uniform. It was as if the signal was born perfectly polarized, its alignment imprinted at the source rather than being shaped by a messy journey through space. This signature is incredibly difficult to replicate with any known astrophysical process. A pulsar's polarization has a specific, recognizable twist to it that this signal lacked. The polarized light from distant quasars is often scrambled by the interstellar medium. This signal, however, arrived with its pristine alignment intact, pointing back to a source within the dust cloud that operates with a strange, fundamental simplicity. It forces us to ask what kind of object or event could generate such a perfectly ordered radio whisper. Is it a natural transmitter we have never conceived of, one that functions with the precision of a laser deep inside a magnetic cocoon? Or does this pure, filtered quality hint at something else, a signal designed not just to be heard, but to be recognized as fundamentally unnatural, a deliberate stroke of order in a chaotic universe? That perfectly ordered whisper was a puzzle, but the eighth signal was a direct contradiction. It erupted from a location within a dust cloud that our maps labeled as an empty void. This was not a dense, active knot where new stars were forming. It was a sparse, quiet region, a cosmic back alley where the dust was so thin and spread out that it should have been radio silent. There simply was not enough material there to generate the kind of powerful emission that flooded our telescopes. It was like hearing a deafening roar from what you thought was an empty, sealed room. This signal challenged a fundamental assumption about these cosmic nurseries. We have always believed that the drama of the universe happens in specific, energetic places, like the fiery hearts of stars or the chaotic crush of stellar birth clouds. We do not expect a powerful voice to call out from the quiet, empty spaces in between. Yet, that is precisely what happened. The signal's origin point was a void within the veil, a place where our models said nothing interesting could occur. So what could possibly be the source? One theory points to a phenomenon known as a maser, which is like a natural laser for microwave light. Certain molecules, like water or silicon monoxide, can under the right conditions amplify radio waves into intense, focused beams. But masers typically require a dense, energetic environment to power them, like the heated gas around a newborn star. Finding a powerful maser in such a diffuse region is like finding a single, brilliantly lit spotlight shining in the middle of a vast, dark, and empty desert with no visible power source. Another, more speculative idea involves a rogue object passing through. Imagine a lone, dense neutron star or a small black hole, invisible to our optical telescopes, drifting through this empty part of the cloud. As it moves, its immense gravity could interact with the wispy traces of dust and gas, squeezing and heating them just enough to trigger a brief, powerful burst of radio emission. The object itself would remain hidden, but its gravitational wake would light up for a moment, creating the illusion of a signal from nothing. This signal forces us to reconsider the dust clouds themselves. Perhaps they are not just simple blankets of dust, but are filled with hidden structures and rogue objects we cannot directly see. The empty spaces on our maps may not be empty at all. They may be hiding engines of incredible power, so strange and subtle that they only reveal themselves in fleeting, brilliant flashes, rewriting the rules of where cosmic energy can be born. The hidden engines within these dust clouds revealed yet another layer of their complexity with the ninth signal. This was not a whisper confined to a single radio frequency. It was a cosmic event that announced itself across the entire spectrum of light. At the very same moment our radio telescopes detected a sharp spike, our infrared eyes in the sky saw a specific patch of the dust cloud begin to glow with a faint, warm heat. This multi-wavelength correlation is the astronomer's equivalent of hearing a crash and simultaneously seeing the flash of breaking glass. It tells us that whatever happened was not a simple, one-off event. It was a complex, multi-stage process, a chain reaction of energy unfolding deep within the dusty veil. Most natural cosmic signals are specialists, a pulsar beams radio waves. A young star floods its surroundings with infrared light as its warmth heats the surrounding dust. But for one object to produce a coordinated pulse in both radio and infrared at the exact same time is incredibly rare. It suggests an engine that operates on multiple fronts, releasing its energy in different forms as part of a single, integrated phenomenon. Imagine a single switch being flipped, causing a light to turn on and a bell to ring simultaneously. That is the kind of coordinated, multi-part event we are talking about. So what could possibly flip that switch? One compelling theory involves a stellar outburst. A young, tempestuous star buried within the cloud might have experienced a massive flare, a stellar tantrum of epic proportions. The initial flash of energy could have sent a shockwave racing outwards at incredible speeds. This shockwave would then do two things almost at once. First, as it accelerated charged particles trapped in the star's magnetic field, it would generate a burst of radio waves. A split second later, that same wave would slam into the surrounding wall of cold dust, heating the tiny grains until they shone with a faint infrared glow. The entire event, from the initial flare to the heated dust, would be a single, violent episode visible across multiple wavelengths. Another, more exotic possibility is the presence of a microquasar, a small-scale version of the violent engines that power distant galaxies. This would be a stellar mass black hole feeding on a companion star. As material spirals into the black hole's accretion disk, it heats to incredible temperatures, emitting energy from radio waves up to X-rays. The precise coordination of radio and infrared light could be the signature of a specific instability in this disk, a sudden dump of material that triggers emissions across the board. The presence of such an object hidden inside a dust cloud would be a monumental discovery, a tiny, furious dragon lurking in its smoky cave. This multi-wavelength signal forces us to stop thinking of these mysteries as simple radio anomalies. They are not just beeps in the dark, they are full-spectrum phenomena, their stories written in radio waves, infrared light, and perhaps other energies we have yet to correlate. To understand them, we cannot just listen with one ear. We must learn to see the universe in all its colors at once, peeling back the dusty layers to witness the intricate, energetic ballet happening within. That multi-sensory event was still being analyzed when the 10th signal introduced a new kind of movement. This transmission did not burst or fade. Instead, it drifted. Its frequency, the very pitch of its cosmic note, began to slide steadily downward over the course of several weeks, like a singer holding a single note while slowly sliding down a musical scale. This persistent shift was not a random fluctuation. It was a smooth, deliberate glide, a change so consistent it felt orchestrated. The most immediate explanation for such a frequency shift is the Doppler effect, the same phenomenon that makes a passing ambulance siren drop in pitch as it speeds away from you. This led to a startling conclusion. The source of the signal itself was in motion, and it was moving away from us at an incredible and potentially accelerating speed. But this raised more questions than it answered. What kind of object embedded deep within a relatively static dust cloud could achieve such velocity? Was it a runaway star ejected from a stellar nursery by a gravitational slingshot? Or perhaps something more exotic, like a neutron star rocketing through the cloud, its powerful lighthouse beam sweeping across space as it fled? Yet the motion implied by the Doppler shift was almost too clean, too perfectly linear for such a chaotic environment. This pushed scientists to consider more radical possibilities. Perhaps the frequency shift was not caused by the source moving through space, but by the space itself changing around the source. One theory suggests the signal was passing through a region of the dust cloud permeated with exotic matter, a hypothetical substance with strange quantum properties. As the radio waves interacted with this exotic medium, their energy could have been slowly sapped, causing their frequency to red shift in a way that perfectly mimics the Doppler effect. Another, even more mind-bending idea involves the dust cloud not as a simple collection of particles, but as a dynamic entity with its own internal flows and currents. Imagine the signal originating from a fixed point, but the cloud itself is rotating like a vast, slow whirlpool. The material between us and the source would be constantly changing, creating a shifting lens that could gradually alter the signal's frequency over time. Each of these hypotheses paints a different portrait of the dust cloud's hidden interior. It is either a cosmic highway for high-speed objects, a laboratory for exotic physics, or a fluid, dynamic structure of immense scale. The drifting signal offers no easy answers, only a profound clue. It tells us that the mysteries within these clouds are not static. They are alive with motion, their hidden sources dancing to a rhythm we are only just beginning to perceive. The drifting signal's motion was still being mapped when the 11th mystery arrived as a cosmic ghost. This signal was faint and distorted, its edges blurred as if it had traveled an impossible distance. careful analysis revealed a startling possibility. It was not a live transmission. What we were hearing might be a faint echo, a reflection of a much older, more powerful event that occurred long ago, its original voice now lost to time. The dust cloud itself could be acting as a giant cosmic mirror. Imagine shouting into a vast, empty canyon. Long after your voice has faded, a faint, distorted echo returns, bouncing off the distant walls. This signal could be the astronomical equivalent, a remnant of some ancient cataclysm or broadcast that briefly illuminated the cloud, with its light and radio waves scattering off dust grains, and only now, after a long and winding path, finally reaching our telescopes. This idea completely transforms our understanding of the cloud's history. If the echo is real, it means the cloud was witness to a moment of immense energy in its deep past. Perhaps a star went supernova nearby, flooding the cloud with radiation, or two neutron stars collided in a spectacular kilonova explosion. The echo we detect today would be the final, fading whisper of that violent, bygone event. But there is another, even more profound implication. What if the original event was not natural? The faint, structured nature of the echo has led some to wonder if we are hearing the reflection of an ancient, artificial broadcast. A powerful signal deliberately sent by some intelligence millions of years ago could have traveled through space, struck this dust cloud, and scattered, with one tiny, fragmented piece of it accidentally bouncing in our direction. We would not be receiving the message directly, but rather a single, faded photon from a cosmic bulletin board, a message so old its senders may be long gone. Detecting such an ancient echo would be like finding a single, weathered page from a library that burned down in prehistory. We could study its texture, its material, and guess at its content, but the full story, the complete work, would be forever lost. This signal forces us to listen not just to what is happening now in the cosmos, but to what happened eons ago. The dust clouds are not just hiding present-day mysteries. They are archival vaults preserving the faint, ghostly echoes of the universe's forgotten moments, and we may have just overheard one of its oldest, most fragile secrets. The ghostly echo had barely faded when the universe delivered a signal of startling coordination. The 12th transmission arrived as a perfectly synchronized duet between the invisible and the unseen. At the precise moment our radio telescopes picked up a sharp, narrow-band pulse, our infrared observatories witnessed a small, contained patch of the same dust cloud suddenly flare with heat. It was not a gradual brightening, but a sudden flash, a brief, intense spark of thermal energy that winked into existence and then vanished, perfectly in time with the radio cry. This was not a coincidence, it was a cause and effect captured in real time, a single event announcing itself in two different languages of light. The immediate question was one of sequence. Did the radio pulse trigger the infrared flare, or did some deeper, hidden cataclysm produce them both at once? The answer paints a picture of violent and beautiful physics. Imagine a deeply buried star, a young, tempestuous sun shrouded in its own dusty cradle. This star could have experienced a hyperflare, a magnetic eruption orders of magnitude more powerful than anything our sun has ever produced. In this single cataclysmic moment, the flare would have sent a storm of charged particles racing out along the star's powerful magnetic field lines. The sudden acceleration of these particles would have generated the sharp radio pulse we detected, a scream of electromagnetic energy. Almost simultaneously, that blast of radiation and particles would have slammed into the surrounding cocoon of cold dust. The tiny grains, mostly silicates and carbon, would have been instantly superheated, glowing brilliantly for a few moments before rapidly cooling back down, creating that brief, matching infrared flash. This single, unified model explains the perfect synchronization. The entire event, from the stellar tantrum to the heated dust, was a chain reaction unfolding in a fraction of a day, a single cosmic finger snap heard in radio and felt in heat. But this elegant explanation only deepens the underlying mystery. What could cause a star to unleash such a perfectly timed, focused outburst? The energy required is staggering, suggesting a stellar environment far more extreme and volatile than we typically find. It hints at a hidden population of adolescent stars with ferocious magnetic personalities, stars that do not just smolder but periodically erupt, their violent growing pains echoing through the dusty voids. Or perhaps the synchronized flare points to something even more compact and energetic than a young star. Could the true engine be a microquasar, a stellar mass black hole feeding on a companion? A sudden instability in its accretion disk, a clump of matter falling in at once, could release a blast of energy capable of producing both the radio and infrared signature in a single, devastating release. The synchronization is the clue that ties it all together, forcing us to see these dust clouds not as passive veils, but as active, energetic landscapes where hidden forces occasionally rip through the silence, leaving behind a coordinated signature that we are only just learning to read. This 13th signal was so unnervingly clean it seemed to defy the universe's natural tendency toward chaos. Its bandwidth was impossibly narrow, a single, pure tone on the cosmic radio dial, a feat of precision that stands in stark contrast to the messy, broad-spectrum noise generated by every known natural object. Stars, pulsars, and quasars all broadcast across a wide range of frequencies, their signals smeared and blurred by the violent processes that create them. This signal, however, was a laser beam in a universe of flashlights, a note of such perfect clarity it felt almost sterile. This characteristic of narrow bandwidth is exactly what our own engineers strive for when designing communication systems, because it packs the most information into the smallest, most efficient slice of the spectrum. Finding such a signal emerging from a turbulent dust cloud, a place of violent birth and random collision, was like hearing a flawless digital recording playing from deep inside a thunderstorm. The scientific community immediately began a rigorous process of elimination, searching for any conceivable natural process that could act as such a precise cosmic transmitter. They first looked to atmospheric masers, natural amplifiers that can produce relatively narrow beams. But even the most powerful cosmic masers, powered by the intense energy of star formation, have a bandwidth thousands of times wider than this signal. Its purity was on another level entirely. Another theory proposed a highly specialized form of quantum emission, perhaps from a unique molecule or atom undergoing a transition so specific it emitted radio waves at one exact frequency. Yet for this to be detectable across interstellar space, it would require a staggering number of these atoms or molecules all acting in perfect, coherent unison, a level of organization that nature simply does not produce in the cold, dark emptiness of a dust cloud. Each natural explanation was stretched to its breaking point, unable to account for the signal's artificial-seeming perfection. This leaves us with a profound and unsettling possibility. Could this be the one, the signal we have always listened for, a transmission so deliberately crafted to stand out that its very cleanliness is its signature? It is a whisper from the dust that challenges our most fundamental assumptions, forcing us to ask if we are finally hearing a voice that intended to be heard. While the 13th signal taunted us with its artificial perfection, the 14th delivered a single, thunderous word and then fell silent forever. This was a transient, a one-off burst of immense power that erupted from the dust and then vanished without a trace. It was a cosmic flash in the pan, a door slamming shut in the dark after a single, blinding glimpse of the room beyond. Astronomers have a name for these events, fast radio bursts, but this one was different. It came from deep within a dust cloud, a location that should have suppressed such a raw, explosive release of energy. The initial detection was a moment of pure excitement, a spike on the graph that promised a new mystery to solve. Teams around the world immediately pointed every available dish back at that same patch of sky, listening intently for a repeat performance, for a second clue that would help them unravel the event. They listened for days, then weeks, then years. They are likely still listening today. The signal never returned. This is the profound frustration of studying transient phenomena in the cosmos. You are trying to piece together the story of a lifetime from a single, fleeting snapshot. Imagine a detective arriving at the scene of a crime to find a single, perfect footprint, but no body, no weapon, and no other evidence of any kind. The footprint tells you something happened, but the story of what and who is lost forever. This single burst is that cosmic footprint. Its power tells us the event that caused it was cataclysmic, perhaps the final, dying breath of a strange object we have never seen. It could have been the collision of two incredibly dense asteroids made of pure iron, or the final, spasmodic flare of a magnetar, a neutron star with a magnetic field so powerful it can tear atoms apart. It might even have been the signature of a microscopic black hole evaporating out of existence in a flash of Hawking radiation. Each of these theories is plausible, yet with only one data point, we cannot choose between them. The signal's refusal to repeat makes it uniquely maddening. Other mysteries, like the repeating whisper from Orion, offer more chances, more data. They are conversations. This was a statement delivered once and never again. It forces us to confront the sheer randomness and solitude of cosmic events. For every signal that patiently repeats, there may be 1,000 that shout only once into the void, their stories eternally unfinished, their origins forever locked away in the silent, swirling dust. 15 years after the data was first recorded, a graduate student running a new pattern recognition algorithm made a startling discovery. The 15th signal had been hiding in plain sight, buried within the immense, silent archives of a radio telescope survey. It was not a shout, but a subtle, structured whisper that had been automatically filtered out years earlier by software designed to ignore terrestrial interference and instrumental glitches. We had been looking at the data for over a decade, but we never truly saw it until a smarter set of digital eyes knew what to search for. The signal was a faint, repeating pattern, a sequence of pulses with a mathematical elegance that simple noise could never possess. It had been there all along, waiting for us to develop the tools to hear its quiet voice. This revelation sends a shiver down the spine of any astronomer. How many other cosmic secrets are lying dormant in our data vaults, obscured not by distance or dust, but by our own technological blinders? Our archives are vast libraries of cosmic history, but we have only just learned how to read a few of the languages they are written in. Every time we develop a new algorithm, a new way of processing this old information, it is like being given a new lens for a microscope, revealing a hidden world that was present all along. This particular signal, now recovered from obscurity, adds another layer to the mystery of the dust clouds. Its pattern was not random, but it also did not match any known celestial rhythm. It was something new, something that had been broadcasting quietly while we were simply not equipped to listen. The implications are staggering. We are no longer just searching the skies. We are researching our own past, mining our collected memories of the cosmos for treasures we were once too blind to see. What else is hiding in those petabytes of old observations, waiting for the right moment and the right mind to finally bring it into the light? This subtle whisper from the data archives was soon challenged by a signal that seemed to mock the very idea of randomness. The 16th transmission was a chaotic hiss, a burst of static that at first sounded like nothing more than the universe's background fizz. But when researchers ran its raw data through sophisticated statistical filters, something startling emerged. Hidden beneath the apparent noise was a faint, incredibly complex pattern, a sequence of pulses that defied any simple mathematical description. It was not a clean, repeating rhythm, but a layered, intricate structure like a faint watermark pressed into the static. The debate this discovery ignited was immediate and fierce. One camp of scientists argued this was a clear case of pareidolia, the human tendency to find meaningful patterns in random data. We see faces in clouds and hear words in the white noise of a fan. Were these researchers desperate for a signal, simply doing the same thing with cosmic static? They pointed out that with enough computational power, you can find seemingly significant patterns in any sufficiently large set of random numbers. It is a statistical illusion, a phantom in the machine. The other camp, however, insisted this was different. The pattern they identified had a specific mathematical signature known as low algorithmic complexity. In simple terms, a truly random sequence is maximally complex. It takes a huge amount of information to describe it. A simple, repeating pattern, like a pulsar's beat, has very low complexity. This signal, however, sat in a strange middle ground. Its pattern was complex, but it could be described by a relatively short set of mathematical rules, suggesting it was generated by a process with underlying structure, not pure chance. It was like comparing a long, random string of letters to a sonnet. Both are long, but the sonnet has a structure and rules that allow you to compress its description. The critics countered that even this could be a fluke, a rare but inevitable alignment in the chaos. They ran simulations showing that in a universe full of noise, such apparently structured patterns will occasionally appear by pure luck. The debate remains unresolved, a perfect encapsulation of the entire search. It forces us to confront a fundamental question about our place in the cosmos. Are we alone and therefore primed to see ghosts in the machine, or are we on the cusp of a discovery so profound that our own skepticism is the final barrier? This signal, hidden in plain hearing, asks us not just to listen, but to decide what we are willing to believe. The debate over patterns hidden in noise was suddenly reframed by a signal emerging from the very cradle of worlds. Signal 17 arrived not from a generic dust cloud, but from the heart of a protoplanetary disk, a vast spinning platter of gas and dust caught in the act of forging new planets. This was a cosmic construction site, and it had just begun to broadcast. The signal itself was a complex, fluctuating hum, its intensity rising and falling in a way that mirrored the turbulent processes of planetary birth. The immediate and most profound question was whether we were listening to the natural soundtrack of creation or something else entirely. On one hand, the signal could be a completely new type of planetary birth cry. As infant planets or planetesimals collide and merge within the disk, they release colossal amounts of energy. This could generate shock waves that ripple through the magnetized dust, creating powerful, fluctuating radio emissions. We could be hearing the roar of 1,000 mountain ranges slamming together in the dark, the raw, chaotic sound of a solar system being built. But there is another, more unsettling possibility. What if the signal is not a byproduct of the process, but a signature of its maturity? Protoplanetary disks are the only places we know where planets can form, and therefore, the only places where life as we understand it could potentially arise. Could this signal be a marker, a beacon placed by an intelligence that has already emerged from such a cradle, a way of saying that this particular construction site is occupied or was once successful? Or, in a scenario that stretches the imagination to its limit, could the signal itself be a form of engineering? The structure of the emission is so tightly linked to the disk's dynamics that some have wondered if we are witnessing not just a natural process but a managed one. Is it conceivable that an advanced technology could use directed energy to influence the formation of planets, steering the chaotic dance of dust and rock, and that this signal is a side effect of that incredible manipulation? The very dust that forms worlds may also be carrying a message about their creation, leaving us to wonder if we are hearing the random noise of a cosmic workshop or the deliberate hum of a carefully tuned machine. The 18th signal arrived with a nervous, flickering quality, its intensity dancing and wavering with a frantic energy. This was not a clean, steady tone, but a beacon seen through a raging cosmic storm. Astronomers call this effect scintillation, the radio equivalent of a star's twinkle in Earth's atmosphere. But this was different. The twinkling was far too extreme, far too rapid to be caused by the general, diffuse sea of electrons between the stars. This violent flicker was a local phenomenon, a fingerprint of a specific kind of turbulence within the dust cloud itself. The signal's journey to us was not a straight shot through empty space. It had to pass through the heart of the cloud, and that passage left a dramatic imprint. The flickering tells a story of a deeply disturbed environment. It reveals that the dust cloud is not a uniform, fluffy blanket. Instead, it is laced with incredibly small-scale structures, dense knots and wispy filaments of gas and dust, all churning and swirling at tremendous speeds. Imagine trying to watch a distant lighthouse through a blizzard. The light does not just dim. It flashes and dances as the snowflakes, each one a tiny lens, constantly shift and move in the violent wind. The signal's scintillation is the radio version of that blizzard. Each flicker corresponds to the signal passing through one of these dense, turbulent patches within the cloud, each one acting as a tiny cosmic lens, bending and scattering the radio waves on their way to our telescopes. The extreme nature of the flicker points to the sheer violence of this hidden environment. The structures causing it must be incredibly compact and moving at high velocities, creating a cauldron of interference that the signal could not escape. This transforms our view of the dust cloud from a passive veil into a dynamic, almost chaotic entity. It is not merely hiding the source of the signal. It is actively shaping the signal's character, imprinting its own turbulent personality onto the message we receive. We are not just listening to a voice from the dust. We are hearing the dust itself speak, its own frantic whisper superimposed over the original transmission, a constant reminder that the messenger is as much a part of the mystery as the message. The 19th signal arrived with a companion. At the precise moment our radio telescopes recorded its unique signature, a separate detector on Earth registered the impact of a single hyper-energetic cosmic ray, a subatomic bullet traveling at nearly the speed of light. Analysis showed both the signal and the particle appeared to originate from the same patch of sky, pointing back toward the same enigmatic dust cloud. This was not just another transmission, it was a coordinated strike, a one-two punch of information and energy from the void. Could the dust cloud itself be a cosmic accelerator, a natural particle collider of unimaginable scale? On Earth, we build massive underground rings like the Large Hadron Collider to smash particles together and study the resulting debris. These machines use powerful electromagnetic fields to accelerate protons and electrons to incredible speeds. The conditions within a turbulent, magnetized dust cloud could, in theory, achieve something similar on a vastly larger scale. Intense magnetic fields, twisted and amplified by the cloud's internal motions, might act as natural versions of our accelerator's magnets. Vast shockwaves from newborn stars or stellar explosions could provide the initial push, sending charged particles surfing on these magnetic waves, gaining energy over immense distances until they are flung out into interstellar space as cosmic rays. In this scenario, the radio signal we detected could be the flash of light from the acceleration process itself, the radio wave scream of a proton being whipped to near light speed. The cosmic ray was the bullet leaving the barrel, and the signal was the muzzle flash. This elegant explanation paints the dust cloud as an engine of fundamental physics, a place where the universe forges its most energetic particles. Yet the coincidence is almost too perfect. The chances of detecting both the fleeting radio signal and the specific cosmic ray from the same distant cloud at the same exact moment are astronomically small. This forces a more radical question. What if the two are not just related, but are different aspects of a single, unimaginable event? Perhaps something deep within the cloud, a phenomenon we have no name for, can simultaneously generate a focused radio emission and hurl a massive particle across the galaxy. The implications ripple outward, suggesting that these dusty veils are not just hiding objects, but are themselves active participants in the cosmos's most energetic dramas, capable of acts of creation and destruction that we are only beginning to witness. This 20th signal did not just speak, it left a chill in its wake. After the transmission faded, astronomers monitoring the dust cloud noticed something unprecedented. A specific region of the cloud, the exact origin point of the signal, began to cool. The temperature of the molecular gas in that area dropped by a measurable, significant amount. This was not a gradual cooling over eons. It was a localized thermodynamic event, a cold spot that appeared right where the mysterious radio voice had been. It was as if the signal itself had siphoned energy from its surroundings, leaving behind a pocket of unnatural cold. Our current understanding of astrophysics has no simple explanation for this. Energy, especially in the cold, sparse environment of a dust cloud, tends to dissipate as heat, not concentrate cold. Think of a light bulb. When you turn it on, it gets hot, warming the air around it. It does not make the air colder. This signal behaved in the opposite way, like a cosmic refrigerator that switched on for a brief moment. So what could possibly draw thermal energy out of a cloud of gas? One theory points to a process called adiabatic cooling. This occurs when a gas expands rapidly, like the air escaping from a pressurized can, which feels cold to the touch. Perhaps the event that generated the signal also sent a powerful, expansive shockwave through the cloud. This wave would have pushed the gas outward, forcing it to expand and cool rapidly. In this model, the radio signal was the sound of the initial explosion, and the cooling was the resulting cosmic exhale. Another, more exotic idea involves exotic matter itself. Certain theoretical particles could, in principle, absorb thermal energy from their surroundings in a unique way. If the signal was a byproduct of such an interaction, a brief flash of particles converting ambient heat into radio waves, it could account for both the transmission and the subsequent temperature drop. The cloud would have provided the power, and the signal was the spent energy radiating away, leaving a temporary void of warmth. This chilling effect adds a profound new dimension to the mystery. These signals are not merely messages or anomalies. They are active forces capable of altering the very environment from which they emerge. We are no longer just listening to whispers from the dust. We are witnessing them reach out and change their world, leaving behind a silent, cold signature that challenges everything we know about energy and the cosmos. The cold left behind by the 20th signal was still dissipating when the 21st offered a glimpse of cosmic music. This transmission was not a single note, but a chord, a set of harmonically related frequencies that rang out together. Imagine striking a piano key and hearing not just its fundamental tone, but a cascade of perfect octaves, fifths, and thirds resonating in flawless mathematical alignment. This harmonic series is a pattern deeply embedded in the physics of our universe, from the vibrations of a guitar string to the orbital periods of planets. Its appearance in a radio signal from a dust cloud should, in theory, be a comforting sign of natural order. Yet the specific arrangement of these harmonies defied every satisfactory explanation. In known astrophysical objects, harmonic relationships do occur. A pulsar, for instance, can sometimes emit at its primary rotation frequency and also at double that rate. But these are simple, brute force harmonics, often messy and accompanied by a riot of other noise. The harmonics in this signal were different. They were numerous, clean, and precisely spaced, forming a complex yet coherent structure that felt more composed than chaotic. It was the difference between the random, overlapping sounds of a junkyard and the deliberate, interlocking notes of a string quartet. Scientists scrambled to find a natural engine that could produce such a pure, multi-layered chord. They modeled collapsing dust clouds and vibrating magnetic field lines. They simulated shockwaves propagating through plasma. While these models could produce simple harmonics, they could not replicate the intricate, layered quality of this signal without also generating a host of other frequencies that simply were not there. The signal was too clean, too musically perfect. This perfection is what pushes the mystery into the realm of the profound. The harmonic series is the foundation of human music and the mathematics of resonance. To find it etched into a radio signal from the void feels like recognizing a universal language. It forces us to confront a tantalizing, almost philosophical question. Are we listening to the signature of a new and incredibly elegant type of natural oscillator, a celestial instrument whose strings are woven from space-time itself? Or does this harmonious chord represent something else, a message crafted not just to be noticed, but to be understood as a product of intelligence, a mathematical hello from the dust? The universe's harmonious chord had barely faded when the 20-second signal arrived from a place of profound silence. It emerged not from a vibrant stellar nursery, but from an exceptionally dark and cold molecular cloud, a cosmic void so quiescent it was considered a dead zone. These regions are the true backwaters of the galaxy, where the density of dust is so high it blocks out starlight, and the temperature hovers just a few degrees above absolute zero. In such a frigid, stagnant environment, the frenetic energy required to generate a powerful radio signal simply should not exist. It is the astrophysical equivalent of hearing a clear, strong voice calling out from the heart of a sealed, soundproof room. The very presence of a signal here challenges our most basic assumptions about where cosmic activity can occur. We expect radio emissions from the violent births of stars, the explosive deaths of others, or the powerful engines of black holes. We do not expect them from a place where time itself seems to have slowed to a crawl, a cloud so dormant it has essentially opted out of the galaxy's ongoing story. The signal's strength is another layer of the puzzle. It was not a faint whisper lost in the cold. It was a robust transmission, implying a source of significant power residing in a place that offers no obvious fuel. This forces a radical rethinking of what might be hidden within these cosmic iceboxes. One theory suggests the presence of a rogue planet, a world flung from its solar system and now drifting alone through the deep freeze. Such an object, if it possessed a strong magnetic field and a volcanic interior, could potentially generate radio emissions through interactions with the tenuous cloud material. Yet the power required for the signal we detected would demand a planetary engine of unimaginable ferocity. Another, more speculative idea points to the dark matter itself. Could this signal be an indirect signature of dark matter particles, which are thought to cluster in these dense clouds, occasionally colliding and annihilating in a way that releases a burst of detectable energy? This would be a discovery of monumental importance, a direct line to the universe's most elusive component. Or perhaps the cloud is not as dormant as it appears. What if we are witnessing the final, single flare of a failed star? A brown dwarf so cold and faint it was invisible to us, experiencing one last magnetic convulsion. Each explanation stretches the limits of plausibility, revealing how little we truly understand about the quietest corners of our galaxy. This signal from the dark proves that silence can be the greatest disguise and that the void itself may be hiding the most profound secrets of all. The 23rd signal arrived with a volume that was physically jarring. Its intensity was calibrated for a source relatively nearby, perhaps a few hundred light-years away at most, yet every measurement we had placed its origin in a dust cloud so remote it should have been a mere whisper. This was a cosmic shout that had crossed an immense void without losing its force, as if the rules of physics themselves had been suspended for its journey. Radio waves, like light, obey the inverse square law. Double the distance from a source and its signal strength drops to a quarter. This fundamental rule is the bedrock of astronomy, allowing us to gauge the power and location of everything from distant galaxies to nearby stars. But this signal broke that rule spectacularly. It was like someone whispering in your ear from the other side of a football field, their voice perfectly clear and undiminished by the space between you. The implications are staggering. Either our measurement of the distance is catastrophically wrong, or the signal was generated with a power so far beyond our comprehension that it makes a supernova look like a matchstick flame. If the distance is correct, the energy required to make the signal appear this bright from so far away is almost unimaginable. We are talking about the total energy output of a star like our Sun, concentrated into a single, focused radio burst. What natural engine could possibly be that efficient, that powerful? One radical theory suggests the signal did not travel directly through space as we understand it. Perhaps it was focused by a gravitational lens, a natural telescope created by the warping of spacetime around a massive object. A perfectly aligned black hole or cluster of dark matter could, in theory, have bent and concentrated the signal's path, funneling its energy directly toward us and amplifying its apparent strength. It would be a 1 in a billion cosmic coincidence, a perfectly aimed spotlight in the dark. Another, more unsettling possibility is that our understanding of the interstellar medium itself is flawed. What if the vast tracts of space between that distant cloud and Earth are not the sparse, dispersive sea of electrons we believe them to be? What if they contain some unknown, energy-preserving quality that allows certain signals to travel vast distances without the expected loss? This signal does not just challenge our models of cosmic engines, it challenges our most basic map of the universe's empty spaces, suggesting that the void itself may be stranger than we ever dreamed. The 24th signal arrived with a rhythm that felt hauntingly familiar. Its strength appears to ebb and flow, not with a celestial clock, but with the passing of our own seasons here on Earth. The correlation is subtle, a faint statistical whisper in the data, suggesting the signal might be slightly stronger during our northern hemisphere summer and weaker in its winter. Every scientist analyzing this pattern knows the truth. This is almost certainly a profound coincidence, a fluke of observation schedules, or a subtle, unknown effect in our own atmosphere that aligns with the calendar. The sheer, mind-boggling improbability of a distant cosmic event synchronizing itself to the tilt of our tiny world is beyond astronomical. Yet, the very idea is a powerful seduction, a narrative that tugs at our deepest desire to be participants in the cosmos, not just observers. It fuels the most imaginative of speculations. What if, against all reason, the signal is directed? The notion of a transmission aimed specifically at our planet, timed to when our hemisphere is most favorably pointed toward its source, evokes a cosmic intelligence not just announcing its presence, but intimately aware of our world's cycles. It suggests a sender who has studied Earth, who knows its orbital dance, and who chooses to speak a little louder when we are best positioned to listen. This seasonal ghost in the data forces a profound, almost philosophical confrontation with our own place in the universe. Are we the intended audience for a message woven into the fabric of space and time, or are we simply witnessing the ultimate example of human pattern seeking, projecting our own parochial rhythms onto the indifferent void? The answer may forever lie beyond our reach, but the question itself reshapes the silence that follows the signal, turning it from mere emptiness into a space filled with infinite, tantalizing possibility. This final signal arrived just months ago, a fresh enigma from the dark that defies our growing list of categories. It does not burst, repeat, or drift. Instead, it paints with color, its energy spread across the radio spectrum in a series of sharp, narrow spikes that resemble a complex molecular fingerprint. Each spike corresponds to a specific frequency, a unique barcode of light that should, in theory, tell us exactly what kind of matter is creating it. Yet when astronomers compare this spectral signature to the known emissions of every molecule ever studied in a lab, from simple water to complex carbon chains, they find no match. It is a ghost in the machine of chemistry, a set of lines on a graph that point to a substance or perhaps a process we have never before encountered. This signal is the current frontier. It represents a shift from simply detecting anomalies to analyzing their fundamental composition, and the composition of this one is entirely new. The very dust that has hidden so many sources is now emitting a signature we cannot decode, as if the cloud itself is made of a strange, unknown form of matter. Or perhaps we are witnessing not a new molecule, but a new kind of energy exchange. The signal could be the product of a quantum phenomenon occurring on the surfaces of dust grains, a reaction so exotic it releases radio waves at these very specific and very unfamiliar frequencies. What we are seeing is the cutting edge of ignorance. For decades, we have listened to the cosmos, confident that we could at least classify the noises we heard. This 25th signal strips away that confidence. It is a modern mystery, proving that the dust clouds are not done surprising us. They are not just hiding old secrets, but actively generating new ones, each one a deeper and more intricate puzzle than the last. The final message from the dust is that the mystery is alive, evolving in real time, and waiting for the next great leap in our understanding to finally bring it into the light. 25 voices from the cosmic dust, each a unique enigma defying a single explanation. From the single, perfect note of Sagittarius to the ghostly echoes of ancient events, from the drifting signals hinting at impossible motion to the chilling cold left in one transmission's wake, this collection demonstrates an astonishing diversity. They are not variations on a single theme, but a chorus of distinct mysteries, each whispering a different secret about the hidden universe. What they collectively reveal is the profound limit of our current knowledge. We have built magnificent telescopes and powerful models, yet these signals slip through the cracks of every category, refusing to be neatly labeled as pulsars, masers, or stellar flares. They are more than mere anomalies. They are proof that interstellar dust clouds are not passive backdrops. They are dynamic, energetic arenas, cosmic laboratories where physics operates in ways we are only beginning to glimpse. These veils of dust and gas are hiding processes and perhaps objects we have not yet dreamed of, each signal a tiny window into a much larger, unseen reality. The story does not end with the 25th signal. It is an ongoing conversation with the cosmos, one that demands we keep listening, keep questioning, and keep looking deeper into the dark. We want to hear which of these cosmic whispers captured your imagination the most. Was it the patient, repeating whisper from Orion, the impossibly clean tone that seemed artificial, or the chilling signature that stole heat from its own cloud? Tell us in the comments which signal you find the most compelling and why. Your curiosity is the next step in this great exploration.